All right, here's the next question. So here we are going to be evaluating an algebraic expression, and the expression is 5 minus 2, and the 2 is being multiplied with y plus 3 all squared. So this one is definitely one where we need to pay attention to the order of operations, and as long as we do that, we might have to deal with a negative here, but I think from there we're good. So we'll plug in 1 for y, and y only appears right there. So let's get after it. We have 5 minus 2, open that parentheses up, plug in 1 for y, and then we have plus 3, and then squared. From here, we'll do 1 plus 3 because we're going to take care of the parentheses first. So we'll take care of this parentheses first, leaving us with 5 minus 2 times 4 squared. Up next, we'll handle the exponent. So 4 squared, that ends up becoming 16. So we have 5 minus 2 multiplied by 16. Now here's where some folks might get a little tripped up. Everyone, we're going to do 2 multiplied by 16, which ends up being 32. But what is that 32 going to be? That 32 will be negative because we have a negative right there, and this is a positive. A negative multiplied by a positive, it remains negative. So we have 5 minus 32, and then from here, we subtract. So here, when you have a positive, subtract a big number, you're really just going to take the difference. You're going to subtract, and you're just going to keep the sign of the bigger number. Clearly here, everybody, 32 is the bigger number, so the answer is going to be negative. So here we are. 5 minus 32, that's 27, but again, it'll be negative. So there's our answer. Answer choice A, negative 27. All right, everybody, so let's try this next one out. This one's a little unique, only because we haven't done it yet in this specific session, but let's go ahead and understand what we are looking at. So we check this out and we see the whole parentheses, x plus 5 all squared. So if you're sitting here thinking, okay, that looks a little funny, I'm not exactly sure what I'm supposed to do. Am I supposed to just square the x and square the 5? No, that is the exact wrong thing that you should do. The correct way of going about this is understanding what squaring is. Now, let me express that. So 3 squared, let's just take a regular number. 3 squared is the same thing as 3 times 3. If we had, everybody, x squared, well, x squared is the same thing as x times x. So what am I getting at with this? What I'm getting at is x plus 5 all squared. That is the same thing as saying x plus 5 times x plus 5. Again, because if you are squaring anything, it is the same as that number multiplied by itself. My party people, before I continue, for those of us that may have been slightly confused on this specific part, does that personally make sense to you? Good. Right on. So again, math is really about understanding the library of rules and definitions to your advantage. That's really what it is. It's a language that you have to learn how to speak. So let's handle this like we know how. X plus 5 times x plus 5. Here we go. The x will multiply with the x squared. Then the x will multiply with the 5x. 5 multiplies with the x, 5x. 5 multiplies with the 5, and that's 25. From here, we're going to move forward here to combining like terms, which are going to exist between these two 5x's. 5x plus 5x gives us 10x. And there we are, everybody. We are all good. There is our final answer, and the correct answer will be answer choice C. And there we go. So just to review this one more time, since it is the first time we saw this. So remember that because we just had this binomial, this x plus 5, all squared, remember that squaring something is just the same as multiplying the same thing by itself. 3 squared is 3 times 3. X squared is x times x. X plus 5 all squared is x plus 5 times x plus 5. And so then from here, we would go ahead and just distribute like we have been doing, and then combine like terms at the end. I saw a question in the chat box that said, hey coach, if this was a 3, so like let's say we had x plus 2 all to the power of 3, that would be the same thing as saying x plus 2 times x plus 2 times x plus 2. That's what it would be, absolutely, because the 3 signals that you're doing it 3 times. So great questions coming out of the chat box there from everybody. I love that. Now let's go ahead and prepare ourselves for this next one. We've got this, and let's get it done. All right, so let's go ahead and take a look at this problem here, where the first thing we always want to do is we want to read that question sentence. And it says, how many cups of sugar were used in total? So again, let's highlight that there. How many cups of sugar used in total? Now, go ahead and answer this for me. As you sit and think about it, when we think about the phrase in total, what operation typically pops up in your head when you think about that? Yeah, and if you're saying addition, yeah, you're absolutely right. The majority of the situations that include in total, typically you have to add everything up, or at least find, everything all together. And that's typically going to be addition, sometimes multiplication. But in this case, when we take a look, it says the lemonade stand used this much sugar in the morning and this much sugar in the afternoon. So it really looks like, to find the total amount of sugar, take this and that and add it all together. And that's what I'll do. I'll have 3/8 and I'll add that with 1/4. And that's how we're going to achieve the answer, just adding this up. Now, the only little detail that we have to address is that when it comes to adding fractions, we have to have the same denominator. In this case, we do not. So here's what we need to think about. The biggest thing about manipulating fractions is whatever you do to the numerator, do to the denominator. That's it. That's pretty much the idea behind simplification, behind like denominators, behind a lot of these ideas with fractions, is just making sure you keep that balance. So with that said, everybody, when we want a like denominator between 8 and 4, first, we always want to ask, can the smaller number go into the bigger number? Because if it can, then it's going to be a lot easier than typical. And let's ask that question here, everybody. Can 4 go into 8? Yeah, the answer is going to be yes, absolutely. What do I multiply 4 by to get to 8, my party people? Yeah, that's going to be 2. Absolutely. So let's just go ahead here and modify this fraction, just this one, by multiplying the numerator and denominator by 2. So there we are. 1 multiplied by 2 in the numerator is 2. 4 multiplied by 2 in the denominator is 8. So we have 3/8 plus 2/8, and now we're good. So as a nice reminder for those of us out there with this refresher problem here, when we add or subtract fractions, we're going to keep the denominator the same. It's kind of like talking about pizza. So this pizza box can hold 8 slices, but there are 3 in there. So 3 out of 8 slices of pizza plus 2 out of 8 slices of pizza, well, that's going to give us 5 out of 8 slices. So boom, there that is. In this problem, we really had to refresh on, well, getting the same denominator when it came to adding fractions, and then just reminding ourselves of the rules and taking care of that therein. But there we are, my party people. The correct answer here is C, 5/8, and I hope you're ready for another one.